I did my project, I developed an application for IEEE's parts store. We started with a parts store using a large Google Docs spreadsheet to track all of our inventory. It was a good idea because it was all online, it was all in one place, but it ended up being a very large file with far too much information to make it easily readable. Modifying one entry didn't modify other things. If we sold the parts kit, we didn't didn't modify the inventory for all the components, and everything had to be manually updated. So what I ended up doing was developing an idea for a new application using Ruby on Rails. It's an advanced web development framework, simple but very powerful, and it removes a lot of the overhead that you commonly see in web applications. The heart of Ruby runs on what's known as a model controller view architecture, which separates the database, the application code, and the page templates that are used to serve the pages to the viewer. Each piece can be modified independently without having to affect the other components. So if you want to change the way something looks on a page, you don't have to recompile the whole code. You just modify a view and re-upload that file to the server. And the end result, you still get an HTML web page that's viewable by the user. The basis of it starts with active record migrations. There are database tables defined in a migration file. The migration command adds defined columns to the table, and you can also use a migration to add to or delete from an existing table. You can also use the migrations to set certain default values for objects in the database. And that's an example of the code that I used to create the parts table and all the columns I put in it. And then later on I decided I needed a currency column, so I had a second migration that I created to add to that. The models they define that the database and the table behavior. It'll handle all data validations, which would be something like, say, a name is required or a price column can't exceed $999 or something like that. You can also have special methods defined in the model that allow you to interrupt the flow of the database actions. And that allows you to do something, say, such as when I cancel a transaction, it has to return all the inventory to the database. If I delete the transaction, all that information is gone. So it interrupts the flow, returns the inventory, and then deletes the database object. And you can use other custom methods within the model more than just these 4 filters. And that's one of the simpler ones. That's just for the parts kits that I've made. And there's a little bit of extra code there that works with the money gem that translates money from an integer to a money object. The controller is where the real application code dwells. It runs on representational state transfer, or REST, which governs the 7 different database actions that you could use, which each of those is mapped to one of the 4 commonly used HTTP protocols. All your database calls will fall within one of these 7 different actions: the new, create, edit, update, index, show, and destroy. You don't have to use all of them in a controller, but if you do put one there, you have to have a corresponding view to work with it. And all it does is it just retrieves the information from the database and passes it to the view. You can have some logic in there to do some complicated things, but usually they're as simple as that, that's the final code that I used for the methods in my parts database. And that's all it was, tiny little pieces. The views are just HTML. There's a special file format called eRuby that allows Ruby code to be executed when the page is generated. It extends the HTML format, so anything you can do in HTML you can do in a view. But it also takes database from the controller, and through these, if anyone's familiar with HTML, you see these tags with percentage on them. That means that I've got a piece of Ruby code embedded in there, and that's taking information from the controller and interpreting that through the HTML. And the Ruby server handles that and then passes an HTML file to the browser. So you never see the Ruby. All you see if you view the page source is the HTML. And that's a layout of all the different elements I put into my site, and I'm going to go over the major ones with you. After logging in, you're presented with a menu. The menu does expand if you log in as an administrator. It just doesn't render that additional option if it detects a shopkeeper. The point of sale system begins with taking the student's email address and entering it in. After that, it passes you to an interface that allows you to select parts from a drop-down list and enter a quantity, and you can keep adding parts in. And you can suspend transactions if you need to. As I said, canceling it will return all of these. Anytime the part's added, it's pulled immediately from the database, so it's reserved. So you can't have two people selling parts at the same time. And clicking complete sale sends an invoice to the student and the IEEE mailbox. So we have a paperless receipt system. The transaction history can give you details about the transaction or just a quick view of all the past transactions. You can edit a transaction through this view, and it will adjust the inventory in the event that mistakes were made, and editing those doesn't resend the email, so you're not constantly spamming the student if you make a bunch of mistakes. The inventory management area, it's just a list of all the parts and the kits that we could have in there. It allows you to view detailed information about the parts or to edit them, and the names of the links to those specific pages. In the detail areas, it gives you more information than is available on the inventory management page. And I added a little extra in there to show a comparison of our cost versus the cost that we're charging for students for these kits. So it's not a pure profit because there's still some other overhead in there, but it's just a good idea to make sure that we are still making money on the kit. And each of these gives you an option to access the editing area as well. I added a simple little function in there that creates a different view to just show name, description, and price, so that an administrator can click on this and it'll pop this information up. They can copy paste it into Excel, do a little formatting, and print it out to post it on bulletin boards around the department for a little advertisement. This was one of the more complicated things I added in. We needed a way to quickly be able to see what parts we are low in. So I've got kits defined in there, and you'll notice that there's a deprecated field. That means that the kit, think of it like a discontinued field. I entered in commonly used parts for the amplifier since there's no kit that's actually provided for that class. And checking off the different kits allows you to enter in the number of students that are going to be taking that course that semester. And the end result is it gives you a nice table of what we currently have and what we need to order. And if what a class needs does not exceed it, it shows 40% of what the nominal value for that part is. So it's just a quick reference. It still needs to be looked over by a human, but it's a quick way to see how we can what we need to order that particular semester. User administration is fairly straightforward. Create, edit, delete user accounts. There's a menu bar that's visible on the site at all times for shopkeepers and admins, and a user can use that to edit all their information, but if they're not an administrator, that security level drop-down does not get rendered, so they can't change their level. This is the front page that I made for the students. It just looks at the database and sees which part is the number of kits we can make, and sets the number of kits for that, and then shows the quantity for all of our parts. And if anything's under 25% of its nominal quantity, it highlights in yellow. If it's 0, it shows up as sold out. And we've got a QR code that I embedded our little sideboard tiger into, so that students can scan that and view this on a smartphone. And it is formatted so that it will show up nicely on a smartphone. So in conclusion, a lot of our popular current web development methods like PHP are cumbersome and slow. Every time you start a new project, you have to reinvent the wheel. You have to tell it every single access that it makes to the database. The courses that I took here showed me that these technologies are strong, but they're not as easy to develop in. And it gave me a launching point to discover Ruby and Rails and use that to develop this website. This simpler development environment allowed me to create a much more well-featured application than I could have with a standard PHP system. And the whole point, or the whole thing I'm taking away from this is modern programming doesn't need to be complicated. It's all just a lot of little parts working together instead of one large complex piece of code. The framework was designed to be easy to use, easy to implement. One of the things I kept coming back to was if it's getting too complicated, I did it wrong. I deleted it and I started over from a different aspect, and usually it became a lot simpler. And these simpler methods end up leading to faster development and better products, which give a company more time to focus on developing more products, which turns into more money. So, any questions?
So does Rails kind of function, its functionality will be similar to PHP in that it's generating the HTML when you hit the page?
That's correct. It's
Okay.
a scripting language, not a compiled language.
Right.
Anything else? Yes?
If I want to buy, order the part, so how do I start? Just click on the URL?
You as a student are not able to order the parts. It's an internal point of sale system, not an online ordering system. So if you were one of the shopkeepers, you'd go in here to either click new sale or begin new transaction, and that gets you to that interface. But the students themselves, I didn't want us to get into a way where students were ordering online and we'd have to have somebody watching for these emails to come in and making packages up and arranging a time to coincide with the students and meet them. So I chose to just make this an internal tracking system with an external view for students to be able to easily see if we have something in stock or not.
So that will be like how other people will know your system will be displayed, or like your advertise, like how students know you are.
Well, the page that I showed you with the conditional formatting, the yellow and the red blocks, that's all we give to the students. We give that to them so they can see a detailed view of what we have in stock, everything that we do carry, and even if we're out of stock at the moment, they can see that we do carry it, but we don't have it right now, and they could come maybe try to work something out with us.
One question. Yeah, I wanted to ask you, how is Ruby different than PHP? And if it's better, how is it better? And the other question is Ruby an open source, or you have to buy it initially?
No, well, I can answer the second first. Ruby is a free open source platform. It's community driven. In fact, if you go out to buy a book on it, your book's probably going to be 6 months out of date because they're actively pushing out new content for Ruby very rapidly. It's a young language, or Rails is a young language. It's only about 10 years old, so it's evolving very rapidly still. Compared to PHP, what makes it simpler is that you're not specifically telling the code, go here, do this with the database, and execute this bit of SQL. You're doing something that says, just get me everything out of the parts table and shove it in this instance variable. And then you have a little block of code that just runs a loop to display all of those items. And then in that block, you tell it which of the fields in the database you want to see. And it's less code to do the same thing. And a lot of what they've done with Ruby is they identified that when you do a project, you can do a lot of the same things over and over again. So the language just assumes you want to do that and takes care of it for you. Bobby, you had a question?
Yeah, is this actually implemented?
This is implemented right now. I chose not to do a live demo because live demos are always asking for but it is active right now. If you go to IEEE-memphis.org/store, you can see the most recent inventory status right now.
Good.
No other questions?
Good,
Thank you.
Dan. If you're going to run a business, inventory is important, right?
Just a little bit. Thank you.